So the next lesson, the first part of it is review from geometry. Now, I realize maybe last year with the quarantine thing, you might not have seen this in class. So we'll just do the best we can here. We're finally at the trig part. There's only one chapter on it. In a normal year, we'd only spend about 2.5 weeks on it. Now, if you're thinking back to last year, this phrase might be familiar. You might remember it. It's kind of the way to the trick to remembering this. It's called SOHCAHTOA. Sounds kind of funny, but I'll explain it. On the front of your calculator and on scientific calculators you used when you were younger, there was 3 buttons: sine, it looks like sin, but it's pronounced sine, and then COS, cosine, and then TAN for tangent. Those are ratios made of the sides of a right triangle. Now, these ratios are given from the perspective, the point of view of one of the other angles, not the 90 degrees. And in each question, you pretend you're looking from that angle. It could be in either place, either the open corners that aren't the 90. Also, we're going to use the Greek letter for angle. It's like an O with a slash through it. The Greek letter theta. It just means angle. It's used all over in math for angle. So these ratios, sine, cosine, and tangent. Sine, angle comes right after the 3 letters. It's the input. This is what the SOHCAHTOA does for us. Sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over adjacent. So sine is O over H, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, TOA, OA, opposite over adjacent. Now, the opposite, the adjacent, hypotenuse, what are those? Well, the hypotenuse you definitely should have heard of before geometry, even probably in middle school. The hypotenuse of a right triangle is the longest side. It's a side across from that 90-degree box. So here's the 90-degree box across from it, and you don't really want to draw this in. I'm just trying to illustrate it for you. This is the hypotenuse. Longest side, the side across from that 90-degree box, is the hypotenuse. Now, the other two, it depends on where the angle is. So you pretend you're standing at that angle. Now, even without math, the word adjacent means right next to. You're at the dinner table and you're sitting next to someone, they're adjacent to you. Picture like a long table. If you had to get up and walk all the way to the other side, that's all the way on the opposite side. So adjacent is right next to you. So this blue guy here is right next to that bottom side. Now he would have to walk all the way through that triangle to get to the other side, so that's on the opposite side. Now we're just practicing labeling these right now. You'll see how this is used in a few minutes here. Now, if we think about the same triangle, but if we put the angle in the other way, on the other angle, this is still the hypotenuse. But now, if you were standing up in this corner, now you're right next to that side. And then all the way across the bottom now is the opposite. So it depends on where they put the angle in the question. Also, they might rotate the triangle around. You just gotta, like I said, pretend you're standing down at the angle. The longest side is always the one across from the box. It's always the hypotenuse, no matter what. And then the other two depends on where you're standing. So here's how these work. Find the measure of each side indicated. Now you notice we only have two sides with anything there on one, x and 16. The blank side is the hypotenuse. We're not going to label that because there's nothing there, so we're not going to use it. Just to keep things less confusing, we'll leave that blank. But we got to realize the blank side is the hypotenuse, so we don't accidentally call the other two hypotenuse. Now, if you're, like I said, they put the angle in the question there, it's 39. You're right next to 16 adjacent. This guy would have to go all the way through the triangle to get to the x, so it's on the opposite side. And here's what SOHCAHTOA does. My hypotenuse is blank. So look at the two letters we have. We have O and A. Now you go through SOHCAHTOA, find the one with O and A. O and H, no. A and H, no. O and A. Hey, there we go. So I'm going to use tangent. That's what the SOHCAHTOA does for you. Allows you to pick out the correct one to use. Tangent. Now, the angle always comes after the three letters, so tangent 39 degrees. It's O first, then A. So x over 60. Now, if I want to get x alone, that's divide by 16, so I'll just multiply. And hey, now I just can pull out my calculator, type that in, and I'm done. The only thing is, on your calculator, I don't know if you got into radians at all in geometry. Radians and degrees are kind of like miles and kilometers, two different ways of measuring the same thing. We're going to use degrees. So your calculator has to be set to degrees. Get mode. So again, I'm in mode. And if you notice right there, radian is picked. If this was a year that you had to take regions, and if last year was as well when you were in geometry, be hounding you every day. Remember to put your calculator in degrees when the first thing you do when you get your regions. Now, anyway, second quit out of there. You can just type this in. The question said 16 times tangent 39 when we solved it. So 16 times tangent 39. Hit enter. 12.9. Now, I don't remember where the question says to round. It says round nearest 10th. So if you bump that 9 up, it becomes 13.0. I'll go back to the notebook now. So 13.0. Number 2. Now this time, when we go to label our sides, we got the box there at C all the way across. That's the hypotenuse. But again, we don't really want to draw those in. If you're standing right at 50.6 degrees, you would have to walk all the way through that triangle to get to X. So that's opposite. The blank side, we're not going to label. Now I can pick out the correct one to use. I have O and I have H. O and H. S. S for sign. Now, like I said, I realize on the calculator it's just SIN, but it's the sign. The angle goes after the three letters SOH. So opposite first, hypotenuse second. Now again, just got to multiply by 7. I'm going to type that in. Type that in right there. And as long as you don't reset your calculator or shut it off, it should still be in degrees. If this was a year where we would be using calculators, like the classroom set of calculators, I would always warn everyone, make sure you check that your calculator is still set correctly. People in earlier classes, especially on test days, might go through and change it to get whoever's going to use it next to make a mistake. Now, anyway, 7 times sine of 50.6, 5.4. All right. Now 3. I'm going to stop switching back and forth from the calculator for now. It's just typing it in. What you see shouldn't be too bad. Now 3. Side across with the box, hypotenuse. And if we had to remember, you pretend you're at the angle. So if I have to walk all the way through the triangle to get to 11.8, that's opposite. So, SOH, we're going to use sine again, sine 71, opposite, so 11.8 over, whoa, okay. So X is on the bottom this time. That adds one extra step. When I get X alone, I want it to say X equals something, not the bottom is X equals something. So we got to get that X up to the top somehow. I'm going to do that by multiplying by X. Cancels it out, moves it over the other side. Now that helps us, because now all I got to do is divide by that sign. When X lands on the bottom, you have an extra step of having to divide by the sine, cosine, or the tangent. First thing you do, you multiply by X, moves it over to the other side, but it's on top now. And you need it to be on top so you can say X equals something. And then you divide by the sine, the cosine, or the tangent, or whatever the question is. You know, I'm not going to go back and switch the calculator again. Instead of times, so 11.8, and hit divide instead, and then just sine button, 71. 12.47, 7 bumps that 4 up to 5. All right, so X again, crossing the box, height. Now, if we're standing at A, at the 27 degrees, we're right next to the 15. So that's adjacent. So we have the A and the H. Oh, hey, look, A and H. C for cosine. We're going to use that for the first time. Cosine, the angles always come after the three letters, so cosine 27 equals, it's A first, then H. So 15 over X. Well, it's one of the extra step ones again. X landed on the bottom. So we'll multiply by X. Then we'll divide by that cosine. Just type it in. 15 divide by cosine 27. 15 divide by cosine 27. 16.83, so 16.8. Now, this next set is different here. As you can see, you don't know the angle. Now, I've mentioned it throughout this year. You know, like I said, maybe you didn't see this as much last year because of the COVID closing of the schools, but hopefully this isn't too bad. Common theme we've had, like exponents and logarithms, or excuse me, exponentials and logarithms or inverses. Input and the output are switched. Same idea here. The page we just did, you knew the angle and you got a length out. Here, I don't know the angle, but I do know two lengths. So my input and my output are swapped. When you look for the angle, you use the inverse sine, cosine, or tangent. You just hit second on the calculator first. In fact, I mentioned it when we went over inverses. Right above the sine, cosine, and tangent buttons are sine -1, cosine -1. That's why we learned that inverses say the -1. Same process almost. Across the box, that's the height. Now, if you're standing at the theta, across from that, all the way on the opposite side. Like I said, we're going to find the angle. So this is different. We have O and H. We're still going to use sine, but now it's inverse sine. The little -1. You put the fraction down, opposite over buttons, 5/13. These are actually easier if you remember to use the inverse. Because all you got to do now is just type that into your calculator. Well, it's like I've said, you know, you can see it now in the blue letters there, sine -1, cosine -1. It's the inverse. Second sine, see it puts a little -1 there. 5/13, you can just use the division, 5 divide 13. Enter. 22.6 degrees, where does it say it around? Nearest tenth, so 22.6 degrees. It's even just a little bit easier than what we just got done doing. Every time you're looking for the angle, you got to use the inverse. You hit the second first. $22.6 degrees. Seven. Okay, cross and box. That 8 is the hypotenuse. You're standing right at theta. You're right next to 3.2, so that's adjacent. Now what happens, whatever angle you're going to be right next to the hypotenuse no matter what. That's why I always try to pick out the hypotenuse first, so we don't accidentally think it's being adjacent. So just be careful. Always think about your hypotenuse first. Now I have A and H. A and H, C for cosine, but I am looking for the angle. I have to use inverse. And 3.2 over 8. There we go. Now the calculator's there. And I don't think it got the calculator. All right. So inverse cosine, just hit second cosine, 3.2 over 8, so 3.2 divide 8. There we go. 66.4 degrees. $66.40. All right. Now, number 8. The blank side this time is the hypotenuse. Now, if you're standing right there at theta, you're right next to 8, adjacent. 10, you'd have to go all the way to the other side, opposite. We have the op and the adj, O and A. So T, tangent, we're looking for the angle. So inverse tangent with a -1. O then A. So 10 over 8. Second tan, 10 divided by 8. Hit enter. 51.3. Number 9. Crossing the box. Hey, we have our height this time. There's something there, 60. Now, if you're standing at theta at B, you have to go all the way through the triangle to get to the other side, so that's off. O and H, inverse sine, 15 over 16. Just type that in. Don't forget to hit second. Sine, 15 divide 16, enter. 69.63, 69.6 degrees. That's just a little quick review of the SOHCAHTOA thing. Now the other, this is really, really easy. So, I'm going to be drawing angles on a coordinate axis. Never done this before, but it's really easy. Now the only thing, when you first plotted points, remembering positive and negative were kind of the first things to do. Right and upper positive, that would land us somewhere in here. So we got to think of positive angles. We start out just like we did with points. We're going to start out in that first quadrant. That's actually counterclockwise for positive angles. If you go the other way, if you go clockwise, That's for negative angles. And in geometry, we learned an angle is made up of two rays. A ray is a line that has one endpoint, but then goes on forever in the other direction. Your initial ray, where you start, is always the positive x. Now, these don't have to be perfect. Just remember, counterclockwise is positive. Think of a full circle. A full circle is 360 degrees. We have four quadrants here, ordered by the axes. So this first would be 90 degrees. Turning around is a 180. 90 more is 270. Now we started out there at 0. So 0 and 360 should make sense. 360, you go all the way around the circle. It's right back to where you started. Now, like I said, this is actually pretty easy here. So 240 is in between 180 and 270. There we go. Now, the only other thing, this was regions. You have to tell me that you understood you were going counterclockwise. So you have to draw a little swirl in there to show you went that way. Done. 12, let's see. Initial rays there, it's always positive x. 90, 180, well, 270, 360 or 0, but I don't even need that. I know 150 is in between the 90 and the 180. And like I said, these don't have to be exact. Just basically show that you know what's going on here. All right, 340, let's see. There's my starting ray, my initial ray. 90, 180, 270, 360. So this one goes almost all the way around. 340. It's pretty close to 360. And you went all the way counterclockwise. Done. 14. 90, 180. So 130 is somewhere in between there. There's my starting. There's my 130. And then just remember, you got to show you went that way. And like, you know, when I say that way, it's the way we're naming the angles. There's 90 degrees. There's 180 degrees, 270, and 360 to get back to where you started. Oh, negative. This is almost the same thing. It's just rotating the other way. So now I'm going to go down kind of. I'm going to go clockwise. Negative 90. Negative 180. Negative 270. Nope. Well, negative 220 is in between negative 180 and negative 270. I forgot to draw the initial, so I just put it in. And then we're going this way. I'm going to remember my initial this time. There we go. Oh, negative again. There's negative 90. Hey, I don't need much more than that. Negative 25 would be somewhere in there. Like I said, these don't have to be perfect. Basically, it's just, hey, do you know what quadrant you're landing in? And you know which way you rotate. Negative again. Initial ray, negative 90. Well, that's not enough. Negative 180. So this one's a little bit into that quadrant. And just remember to put the direction that you headed. Negative 300. Ooh, this one, let's see. There's my initial. Now remember, we're going down this way, so negative 90, negative 180, negative 270. So here, there's negative 300, a little bit more. Rotate it all the way around like that. Negative 140. Well, let's see. There's 0, my initial. We're going down again, kind of clockwise. Negative 90, negative 180. Oop, don't need any more than that. Negative 140 is in between 90 and 180, so there we go. That direction. That one we don't really need. Just trying to illustrate. And oop, there I snuck a positive one in again. So we're going back counterclockwise. We don't need that though. We don't really want that. Just trying to illustrate. 90, 180, 270. You know, I'm just adding 90 there. 360. 345 is almost all the way around the circle. There we go. Hopefully those aren't too bad. Usually, and sometimes they're as easy as like number 20 there. That would be a 2-point question on the regions. Just forget. Like I've said that all year so far. A lot of the hard stuff in this class is just remembering.